Number 5A. Okay, for homework 8. Only 3. I remember there should be more, right? Only 4 people. Please look at homework 8. If you got number 5A wrong, please raise your hand. Okay, so let's go over number 5A now, right? So this one, it tells you that this question is similar. I'll show you where to see the notes. Okay, so you can look at page 23. Okay, page 23, question number 5 is similar to that. Okay, and they give you a point which is on y equal f of x plus 3. Okay, hold on one sec. Okay, so okay, we'll look at 5A. 5A, we have 9, -4. Is on y equal f of x minus 3 plus 1. So where is the point on y equal to 3f of 4 minus x plus 2? Right, so this was the question. So normally they give you the point that should be on the original, right? But then this time they tell you that 9, -4 is on this one. Okay, give me one sec. Okay, sorry about that. Okay, so we have, so you have to pretend, right? If you want to find a new point, you need to find out where it was originally, okay? So first of all, right, we need to find out where is the point is on the original. Okay, so this one, when you are doing correction, right, you can make a note. This one is the original. This one is the after. So they give you a point that's on the after. Okay, so once you figure out where the original is, then you can start from that point to get to the, oh, that's so thick. Okay, to get to the point that we want. Right, you see the green one. Okay, so the plan is to figure out the original point and then use the original point to get the point that we want to get to. Okay, so you have the after, another after, but the green after is the one we want to find. Okay, so let's look at the story for the red after. Okay, from original to the red after What's the story? We have a translation here, right? What kind of story do we have? Okay, so Eric, what do you think?
Like for the after one?
Yeah, for the red after, what's the story
Yeah.
for it?
Y equals f of, or y minus 1 equals f of x minus 3.
Yeah, that's a story form, but what's the story behind it? How do you describe? What does it mean?
Um, you translate 1 unit down and 3 units right.
Yes, okay.
Or
So
was it be 1 unit up?
one unit up, yeah, one up and 3 right. Okay. So that's 1 up, 3 right. So if I want to go back and find the original point, I need to go opposite. Right? So the opposite of 1 up, 3 right will be 1 down, 3 left. Okay? Let me write it down here. Okay? So from here to 9, -4 is 1 up, 3 right. So if I want to go back, I need to do 1 down, 3 left. Okay, so if I do that, 1 down, 3 left, where will the point become? Okay, so Jenny, what do you think? If I go 1 down, 3 left,
Sorry, you cut out. What was the question again?
if you start with 9, -4,
Mm-hmm.
and then you go backwards, right? And then do 1 down, 3 left, where would it go?
Would it? I'm not sure actually.
1 down, does that affect the X or Y?
That affects the Y.
Okay, so the Y was -4, right?
Yeah.
If you move it 1 down, where would it be?
-5.
Yeah. Can you give me the X as well?
Is it 6?
Yeah, it goes to the left by 3. Okay, so 6, -5. That point should be on the original. Okay, and then the 9, -4 is on the function they gave you. Okay, so now you got the original. Okay, original is at 6, -5. Put 6, -5. Now we can start from there to get to the after, the green one, okay? The one they want you to find. Any questions so far? Okay, so you should always find the original first before you try to get to the answer, right? If they give you something that's not on the original, original is the one that has no stories at all. Okay, so now let's look at the green part. Okay, so I'll use the green color. So we need to find the what's happening, or we need to turn that into story form first. Okay, so I'll copy that again. So please change this one into story form. So you should already have it, right? So Susan, what's your story form for this one?
Y minus 2/3 is equal to f function of x minus 4/-1.
Very good. Okay, so this one, the order is reversed, right? So you need to flip it. and then take out the negative. Take out the negative, right? And then move the negative down. So it becomes x minus 4 over -1. Okay, so you want to apply this to the original point. Okay. So your original point was 6, -5. You want to apply and then get the new point. Okay, let's start with the x. So by looking at your story form, how do we get the new x value? Nick, how do we find the new x value now?
You have to like plug it in.
No, you don't need to plug in anything. Remember how you get the points for the new graphs before? Right.
Well, like so you like do like the reflections and like the translations.
Yeah. Okay, so for the x part, what do we need to do?
So that's
What do we need to multiply?
-1
Yeah, multiply by -1 and then
or
plus or minus?
plus.
Yes, okay. So times -1 and then plus 4. So Philip, what do you get?
You get
Times -1.
-2, -13.
Just for the x. For the x.
Oh. So you get -6.
Negative
6.
times -1 will be -6, right?
Yeah.
And then you need to move it to the right. How much move it to the right?
4.
Yeah. So what do you get?
-2.
-2. Okay. All right. So the x, you need to times it by -1 and then plus 4. Right. Now let's look at the y part. Okay, lady, what do you do with the y?
You
Look at the story form, right? What do we need to multiply?
multiply by 3
Yeah, so 3 times the y and then
and then plus 2
because we're moving which way?
because we're moving down.
Y is up or down, right?
Yeah.
So plus, if the story form has a y minus 2, it means goes up.
Yeah.
Okay, up 2. So up 2, it will make the point plus 2. Understand?
Yeah.
Okay, so the final number should be what, Jocelyn? What's the new y values? Jocelyn? Jocelyn, are you there?
Yeah.
Yeah, okay. So what's the y value now? Do you know what to do?
Is it negative 13?
How did you find that number? What
Don't
did
you
you do?
use like 3y the bottom equation? Like
Yeah. So what do you do?
3y
What
plus
times
2.
what? So what times what? 3 times
3 times -5
Yeah, and then
plus 2.
yeah, plus 2. Very good. Okay, so that's how you guys should get -2, -13 on your answer. Okay, so this question involves 2 steps, right? First, you have to get the original point, which you need to think backwards, right? Rewind your tape. Okay, and then which will become 6 -5. After that, you get the original point, then you can apply the new story on the original. Okay, so that's the question. Any other questions you want to go over for homework 8? Okay, the answer key is on Google Classroom, right? So if you want to look at the steps of how other people did it, okay, you can take a look. And then even after today's class, right, in future class, if you ever want to go back and then go over a few questions, we can do that too, okay? Right, so if no question, let's look at homework 9. Homework 9 is trigonometry. We didn't do too much last time, right? Just went over radian and degree mode. Radian measure and degree measure. Okay, do we have any question on that? I think, Marcus, I don't have your homework yet. Marcus,
Oh yeah.
do you have questions about homework 9?
Oh no, I finished it. I just didn't hand it in.
Okay, so please submit it, okay? And how about Evan
I just finished it.
and Jenny?
Finished it. I handed
Homework 9. Did
I
you
handed
submit
it
it?
in. Yeah.
I don't see it.
Let me check. I handed it in on Thursday.
Did you put it at the wrong spot? Homework 9. Yeah, please double
Hold on.
check. Okay, right now it's empty.
Yeah, sorry. I'll hand it in again.
Okay. All right, so okay, I got Evans, I think. Let me see. Yeah. Okay, so I'll check it later, right? So make sure you hand in the homework 9 today. All right, so let's continue, okay? From where we left off, we have quite a lot to cover today, okay? But they are compared to transformation should be easier, right? Just using just some of the new terms, okay? Okay, so let's quickly review what we did last time. We mentioned that the measurement of the angle, it could be using two different units, right? The new units that we learned was called the radian. Okay, so we say the full circle is how many radian, Chris? To complete a circle, how many radian is it?
6, 7,
Hmm?
6.
About 6 point something, right? Yeah, Chris?
Yeah.
Yeah, but we have an exact value for it, right? A 360 degree is the same as how many radian exactly? It's on the screen.
2
2 what?
pi.
Yes, okay. 2 pi pi is 3.14, right? So 2 pi is 6.28. So it's telling you that you could fit about 6 radius. Okay, that's why it's called radian. It has to do with radius. The number of radius you could fit around the circumference. Okay, so to be exact, it will be 2 pi. It takes 2 pi radius, or you call it radian, to fit around the full circle. And that represents 360 degrees. But we can cut it in half and then make it 180 degree, right? And then that will equal to pi. So remember, pi represents half a circle. And then from there, I can just cut into slices, okay? If you cut in half, right, 2 slices, pi over 2. Cut into 3 slices, pi over 3, right? So here we have picture. Easier to remember with a picture. 90 degree, right? 60 degree, 45 degree, 30 degree. 30 degree, you cut into 6 pieces. Okay, so the common ones you need to remember. So now let's take a look. What if the angle they give you is something that's not 30, right? Not those common ones, not 60, 45, those ones. So we need to know how many radian for 1 degree, okay? So over here, right, I want to change 180 into 1 degree. So that means on the picture, this is 180 degree, right? I only want 1 degree. Very tiny, 1 degree. So I need to divide into 180 parts. If we do that on both sides, it will be pi over 180. Make sense? Okay, for example, like if you have, oops, where did it go? Yeah, like over here, we have 1 foot. It's 12 inch, right? You need to know how big is 1 foot. Then you can use that to figure out anything else, right? So now if I ask you how many inches is 5 foot, then you know you need to times it by 5, okay? So 1 is like the unit that you need, okay? So use this one if you want to change. Let's put a picture on the side, okay? Okay, so for the second formula, you will use it when you want to change to radian. Okay, you know how big 1 degree is? For example, I want to figure out 5 degree. Then you multiply by 5, right? 1 times 5 will give you 5 degree. So let's look at an example, right? Look at the bottom here. I want to change to radian, right? The first one, negative 23 degree. So to find this box, we know 1 degree is pi over 180, right? So negative 23, you will take negative 23 times pi over 180. Okay, so you can see the degree will cancel out with the degree. Okay, then you are left with just radian. Okay, so if you type it into the calculator, so everyone take out your calculator. The pi, you could use 3.14 or the pi button on your calculator. Okay, so 23 times 3.14 and divided by 180. All right, so Evan, what do you have?
I got 0.4.
0.40.
01.
1, okay? So that will give you, and don't forget it will be negative, okay? So it should be radian, so you don't need to put a little circle, okay? Do not put a little circle there, that's for degree, okay? Just negative 0.401. So you will multiply by pi over 180 if you want to change to radian, okay? So that's the second formula, right? For anything that's not common. So change to radian. Okay, let me write down the rule, right? Change to radian. If it's changing to radian, you need to have the pi on the top. Okay. Now let's look at a third one, right? What if I want to change to degree? Again, you start with 180 degree is pi, right? So now this time, instead of making 180 become 1, we'll make pi become 1. So 1 radian. Okay, so right hand side become 1. So you need to divide by pi, right? Pi divided by pi will be 1. So left side will also divide by pi. Okay, so if you want to change the degree, then you need to multiply with 180 degree over pi. So the degree is on the top, okay? 180 degree on the top. Okay, so please raise your hand if you finish copying this part. We have 3 conversion rules. The first rule is for common angles, okay? The second one and the third one is for anything else. The common one, you don't need to do multiplying, okay? It still works, but just takes too long, right? So for common ones, you use the 180 degree equals to pi. Okay, so remember, change to radian, pi on top. Change to degree, 180 degree on top, okay? Please raise your hand if you got everything in the box here. Okay, Marcus. Yeah, okay. So let's practice next one, right? For example, here we have 6, right? This is a 6 radian. And I want to get the degree, right? I want to figure out the degree. So let's write it here. To find this one, change the degree, then you should multiply with 180 degree, right? 180 degree on top. So 6 times 180 over pi. Okay, so you can see that the degree sign is on the top, so it won't go away, right? The degree won't cancel out. So one more time, you type it into your calculator. So Angela, what do you have? Angela?
Sorry, give me a second.
Okay.
343.
343. And can you give me 3 decimal places?
0.775.
Yeah, 775. And the unit should be what? Degree or radian?
Degrees.
Yes. So don't forget the little circle at the corner. Okay. So very simple rule, very straightforward. It's just calculator work. And it's easy to mix up the two, right? Sometimes you times pi over 180. Sometimes you times 180 over pi. So the way I remember it Oh, I already tried to help you here, right? If you want to change the radian, pi should be on top. Okay, if you want to change the degree, then the fraction should be degree on the top. Okay, because you don't want to get rid of the degree, right? Shouldn't cancel out. If you do the other way around, right, then the degree will cross each other out. Right, so I'll let you guys finish the rest of the boxes, right? It's just calculator work. Practice these ones. And raise your hand if you finish the boxes. We have 1, 2, 3, 4, 5, 6. Okay, so I ask 6 of you to answer the questions here. Okay, complete the 6 box and raise your hand. And please leave all your answer in decimals, okay? Because all of these are not common, okay? So 3 decimal places for your answer. Three places, okay? Round to 3 decimals. Okay, let's check one of them. All right, Philip, what's your answer for 100 degree?
5 pi over 9.
Decimals, please.
In decimals, that would be 1.7453.
Yeah, okay, 745 will be good. Okay, 3 decimal place. So that's radian, okay, for 100 degree. Right, Waylon, can you tell me the degree for the next one?
I got negative 704.738.
0.738 degree. Okay, don't forget degree sign. Very good. Okay, please raise your hand if you complete all the boxes. For the next two is just showing you that the degree, they could put it in something with a pi, right? Seeing a pi, it doesn't mean it's a radian, right? For example, if I say there's a pi degree, what that means is just saying it's 3.14 degree, right? It's just a number. Pi is just a number. If there's no degree sign, then it's the radian. Okay, does anyone have questions how to use the formulas? Okay, Nick, what's your answer for next one?
0.125.
0.125. I think if you round it, should be 126. If you check calculator.
Oh yeah, 126.
Yeah, okay, round to 3 decimal places. So same with the homework, okay, make sure you round to 3 places. Okay, please raise your hand if you finish all problem. Okay, Jocelyn, how about the next one? The degree for 2.3 pi. Did you find it? This one.
I got 414.
Yeah, very good. Point what? Do we have decimals?
No.
Okay, so no decimal for this one. Okay. Very good. Okay, next one. Jenny, what's your answer for negative 450 degree?
Negative 7.585.
85, one more, 85,
0.
0. Can you check again?
Okay, I will do that.
Yeah.
Okay, I have a completely. Oh no, I hit the wrong buttons. Give me a second. Sorry.
No problem.
Okay, I got the same answer.
Answer. Okay, so probably I think I have 854. Then probably it's because I use the pi button. Okay, so it makes a little difference. Okay.
Okay.
So it will be more accurate if you use the pi button. Okay, so yeah, so make sure you consider that as well. All right, last one. Sophie, what's your answer for last one?
I got negative 229.183.
183. Yeah. Okay, degree. Right, so you will be using the second and the third rule depending on if you want to change the degree or radian. Of course, you can use the same rule for a common one, but what's the point of using the multiplying, right? If they are common, right? Common one, you just cut the slices, count number of slices, okay? And this skill is very useful later, okay? When we try to find other questions, okay? So if no problem here, we're gonna move on to next part, next page. So page 36 is also something we covered before in grade 11 when we talked about angles, okay? Reference angle, principal angle, and here is a coterminal angle. So let's look at just some definition, okay? We'll go over these ones. So co means you share, right? Together. You share together, cooperate, right? You work together. Terminal means the terminal arm, right? Ending, right? The ending place. So if the angle is sharing the same ending place, we call them coterminal angles. So it's very clear over here, right? The picture here. If the angle B, let's say this one is, we're gonna practice radian now, okay? To help you get used to it. So if the beta, right, angle B is pi over 3. Okay. And if I want to keep on turning from pi over 3 and then make a full circle again, right? Pi over 3 is the blue part. And I continue to turn the red part. That's a full circle, right? So a full circle is 2 pi. So the angle A will be pi over 3 plus 2 pi. Okay, how do you add pi over 3 plus 2 pi? You need to get common denominator, right? Just like the way you learn fractions, right? So pi over 3 plus 6 pi over 3, right? Common denominator, so that gives you 7 pi over 3. So the 7 pi over 3 and the pi over 3, they are called the coterminal angle because they both stop at the same place. Make sense? Okay, so that's the meaning of coterminal. So coterminal angles, they are always 2 pi apart, or you can, if you are in degree mode, then 360 apart. Okay, so if you look at here, now look at the definition, right? If angle A and B, they are in standard position, both angles share the same terminal arm. Okay, meaning they stop at the same place. Then they are coterminal to each other. So we have this formula, right? If you want to get angle A, you start, right? B is the beginning angle. You add n times 360. N is like the number of turns. Okay. N is the number of turns. So if n equal to 1, that means you add 360 degree. N equal to 2 means you add 720, right? Because 2 times 360. Okay. If it's in radian, right, then instead of 360, you have 2 pi, right? Because 360 means 2 pi in radian. Okay, so we get these two formulas. If n is integers, okay, number of turn has to be integers. Okay, because it has to be a full turn, right, to get back to the same place, right? If you turn half a turn, then it won't stop at the same place. Then you won't call them coterminal. Okay, so on the side you can write it down. N is I, right? N is an element of I. I stands for integer. Okay, so that's what it's talking about here, the definition of coterminal angles. All right, please raise your hand if you finish copying these notes. And then we're gonna try, okay? Try a few questions. Okay, please raise your hand if you finish writing down the notes here. Okay, Nick and Jocelyn. So the kind of question you will see on the homework, okay, well, one of them will be like this. Here it asks you to find one positive and one negative coterminal angle that is closest to 0 degree. Okay, because coterminal means it can keep on turning, right? So if you go positive coterminal, it can keep on adding 360 forever, right? 1 turn, 2 turn, 3 turns. So on the answer key, right, we don't know which one, how many turns you make. So answer key only shows the one that is closest to 0 degree. Okay, meaning so you don't turn too many, okay? So for example, like the first one, question 8, right? So we want to find the positive first, okay? The positive coterminal. So 215 degree, this one is already positive degree. So 215. If I take away 360, right, that is still coterminal, but it will become negative, right? So I need to do adding, okay? So plus 360 degree. Okay, how big would that become? Philip?
575.
Yep, okay, so the 575 will be the biggest, sorry, the closest to 0 degree, okay? The closest positive coterminal, okay? To 215. So you don't include 215, okay? So other than 215 degree, the one that is closest to 0 is 575. Okay, if you add another 360 degree, that's another coterminal angle, right? But then that's not the closest to 0 degree. Okay, now if we want to get to the negative, okay, I will do 215, right? This is our beginning angle. Instead of adding, I will do subtracting because I want to get to the negative side. Okay, and just subtracting once will be enough, right? Sometimes you might need to subtract more than once, okay? More than one turn. So this one, I just need to turn once. All right, so how big would this one become, Marcus?
It would be negative 145.
Yeah, negative 145 degree. Don't forget degree, right? So these two are the answers that we are looking for, okay? Of course, you keep on subtracting, it will still be negative, right? You subtract another 360, it will be negative what? 505 degree, right? But then that's not the one we want on the answer key, okay? We just want the one that's closest to 0, okay? You subtract too much, then it's still coterminal, but it's not the closest. Okay, so please do question B and C. Or if you have any questions, let me know. Okay, so do B and C and raise your hand. Okay, does anyone feel confused about what to do here? For question C is really negative, right? Negative 2020. So if you want to get to the positive, you need to add more than one term, right? You want to add it until it just barely, right? The first time it becomes positive. Then we call that closest to 0. And same with the negative, right? You don't do subtracting for this one. Because if you subtract, it will be even more negative. We want the one that's closest to 0. So you still need to add, okay? You keep on adding before it becomes positive. Right, let's check the one of the answer, right? For 900 degree. So if we keep all the answer closest to 0, then everyone should get the same answer, right? If we don't have that rule, then some gets more turn, right? Some gets less turns. All right, so Waylon, what's your answer for the positive coterminal?
I got 180.
Okay, and can you tell us what you did?
So basically I just multiplied 360 by 2 and then subtracted that from 900.
Very
So
good.
nine-
So 900 degree, you take away 2 turns of 360. Okay, good. Now for the negative. Okay, Evan, do you have the negative coterminal?
I don't know if it's right, but is it negative 180?
Yeah, what did you do?
I just subtracted by 180 or multiplied 360 by 3.
Okay, so 900, you need to subtract 360 3 times to make it negative. Okay? Okay, Marcus, do you have question C for the positive?
Positive should be, hold on, oh wait, 1 second.
Yeah.
It should be, well, 140.
And can you tell us what you did?
I did, 2000, negative 2020, plus 2160,
So how many turns is that?
6.
Okay, so 6 times 360 degree. Okay, very good. And then last one, the negative. Okay, Chris, what's your answer for negative?
Negative 220 degrees.
And what do you do?
I just minus 360 from the 140.
Yeah, okay, so you make another turn then, right? Well, it turned less, right? You minus 360. So negative 220 degree. Instead of adding 6 turns, we just need to add 5 turns. Or of course, you can go from 140, subtract 360, right? Because as long as you use 360, it goes back to the same arm, okay? So all the angles that you found here, they are all coterminal to each other. All right, next part, question 3. Determine whether the angles are coterminal or not. Okay, so here I give you 2 angles. We want to see if they are coterminal. So if you look at the definition, right? If it's coterminal, then the number of turn has to be integers, right? To make sure it goes back to the same place. So you can either use guess and check, right? Keep on adding 360, see if it hits, or you can use the formula that they give you, okay? So like question A, I'll demonstrate the first one. The formula is A equal to B, right? Plus N 360. I'll write 360N, okay? Have the variable at the back. So A and B, you can use either one, okay? You can A and yeah, okay? You can choose whatever one to be the beginning or the after. So I'm just gonna follow the order, okay? -1485 equals to 1040 plus 360N. So we want to see if the N will end up to be an integer. Okay, so you solve for N. Okay, isolate the N. So everyone try this out. Okay, once you found the N, please raise your hand or check the answer. You can use calculator. Okay, anyone has question about how to solve for N? Okay, please raise your hand if you found N. Okay, Susan, what did you get for N?
-7.014.
Okay, -7.04. Okay, so does that mean they are coterminal or not?
No,
Because,
there's a fraction.
yeah, okay, so it's more than 7 turns, right? A little bit more than 7 turns. So if you see a decimal answer or fraction answer, then this one is no, right? Not coterminal. Okay, if it's something like huge angles like these, you can use the formula, right? Plug it in, right? If something that's smaller, you could just use add and subtract 360 to see if it becomes the other ones. All right, so please do the other 2 questions, question B and C. Once you finish those 2, you can raise your hand. Okay, let's check question B. Okay, Jenny, what do you think question B? Are they coterminal? Jenny?
Sorry, I haven't finished it yet.
Question B?
No, I'm still halfway through.
Okay, so it's still on question B, right? Okay.
Yeah.
All right, let me know, okay, when you finish B.
Okay.
Anyone here got stuck on what to do here? You can just plug it into the formula, right? And then solve for n. Or you can do adding 360, right? Keep on adding 360 or keep on subtracting 360. Since you all have calculator, right? See if you get to the other angle. That also work, right? It's doing the same thing. But then if you are doing that way, right, it can't really show any work, right? If you put it into the formula, at least I can check your work. So I would like you to try use the formula, okay? Also helps you remember the formula too.
I got -4.
So after you plug it in,
Yep.
okay, so if n is -4, what does that tell you then?
Not coterminal?
Is it a decimal?
It is not.
Not a decimal, right? So it's an integer, right?
Mhm.
Okay, if n is an integer, what does that mean?
It is a coterminal?
They
Okay.
are, if they are integer, right? The answer that you found is integer, then they are coterminal.
Okay.
Okay, so it will be yes, coterminal. Okay. You know how to find the n, but you need to know what it means too, right? Jenny, so what number did you plug into the A?
I plugged -759.
Yeah, -759 equal to 681 plus 360n, right?
Mm-hmm.
So -4, it just means that from 681 degree, if you need to turn 4 turns, okay? Negative. In the negative direction, you need to turn 4 times, and then you will end up at -759, okay? So exactly 4 times, then you will end up at the same place. Okay, question C. Okay, if you finish question C, please raise your hand. All right, Nick, what do you have?
It's not coterminal because
Yep.
-382 divided by 360, that gets you -1.06.
-1.061.
0.061. Yep.
Okay, so it's a little bit more than 1 turn.
Yes.
Right, okay, so not coterminal. Okay, so if we plug it in, -11 equals to 371 plus 360n. Okay, you solve for n, you should get a negative number. So it takes more than 1 turn in the negative direction to reach -11 degree. Okay, when you finish everything up to here, can you please raise your hand? Okay, we just have two more names that we need to cover. Okay. The next one is called the reference angle. Okay, reference angle, you've learned it in grade 11 as well. It's an angle that is between 0 to 90 degree. And you see there's an equal, right? So also could be 0 degree. You also count that as a reference angle. So could also be 90 degree. That is formed between the terminal arm and x-axis. Okay, so what that means is, for example, if I draw an angle, I'll draw the angle in standard position. Right, this is a x and y axis, right? If the terminal arm is in the first quadrant, x-axis is this green line, then the reference angle is the one over here, the little dot, okay? If it's in the first quadrant. If it's in the second quadrant, then the angle between the arm and the green line will be this one, okay? Reference angle. And then the third quadrant will be here, right? Fourth quadrant will be here. So these four dots, they are the reference angle. Okay, so the common mistake is to find the reference angle and then use the one at the cross. Okay, so not the one there. It has to be with the x-axis. Okay, so please make sure you draw the picture down, and then you can have four triangles there. Okay, so we're talking about the angle that is close to the x-axis. That's called the reference angle. Okay, we'll talk about the reference, we'll practice reference angle first. Okay, so let's try the first question. First one, we have 500 degree, right? So first of all, we need to know where 500 degree stops at. It turns in the positive angles, right? So we're gonna do that. So positive has to be counterclockwise, right? So 360 degree, right? It's not there yet. How much more do I still need to turn? Lily? 500 degree. After one turn, how much more?
140.
Yeah, so 140 degree more, then that should help us to end up at the second quadrant, right? So that's our terminal arm. Okay, that's the stopping place. So once you get there, then you look at the picture, right? The reference angle, if it's in second quadrant, the reference angle should be this red dot. Okay, so you need to find how big that angle is. Okay, please raise your hand once you found the reference angle. If anyone has questioned how to get it, let me know. Okay, you can just turn on your mic and you say, I don't know. I'm not sure how to get the answer. Okay, let me know so I can help you. But if you found the answer, you can raise your hand. Okay, does anyone have questions how to get this one? Please raise your hand when you finished. Just question A, okay? Reference angle for A. Okay, Marcus, what's your answer for A?
Is it 50?
How'd you get 50?
I did 500 minus 450. What is it?
500 degree minus
450.
450. Where's the 450 come from?
Oh, I just did it to the line. And wouldn't it leave like 50 left over for the angle?
Where did you get the you said 350 or 450, right?
Yeah.
How'd you get the 450, that number?
It was like one full turn and I added 90.
Mm-hmm.
And then I just minused it. I don't know.
Okay, one full turn. Okay, let me draw it out. Okay, let me draw it out. So one full turn is 360, right?
Yeah.
Yeah, and then you say you add a 90. That's only
Yeah.
that's only there,
Oh,
right? We want to get to the arm. So how much do you need to add?
like 50.
Hmm?
Would it be 50 degrees?
50 degree. Oh,
Right. Yeah.
50 degree here and 90 degree there, right?
Yeah.
Yeah, but we are looking for this part.
Oh, 40.
Yeah, okay. We are looking for reference angle. Reference angle is the one that's on with the x-axis, okay? Between the
Okay.
terminal arm and x-axis. Right? So 50 is this part. This is 90, okay? So what you can do is, you know, the whole thing there is 140. Okay, this part, I'll use the green color here. This part is 140. So you can take half a circle, right? Half a circle, the terminal arm is here. This part is 140. So the other part, that's the reference angle. So 180 take away 140. That also works too. So you don't have to break down into 90 and 50, okay? It's more work that way. You just use 180 minus the other half, the other part, okay? Minus 140. Give you 40 degrees. Okay, so you need to draw it out, okay? Draw it out and then see if it's close to the 180 or close to the 360. So always use the 180 degree to find it, or the 360 degree to find it. Okay, so please find the other two questions, okay? Just the reference angle. If you still have questions about question A, let me know, okay? And I'll try to explain differently. Okay, if you finish B and C, you can raise your hand. Find the reference angle. Start by drawing the picture. Okay, we'll check the picture first. So Eric, can I have you show the picture for B? And the terminal arm. Yep, very good. And where, yep, that's the reference angle. Very good. Okay. I'll just trace over yours, okay? So reference angle is the red dot. Okay, so kind of similar to question A, right? Instead of 140 degree, we have 102 degree. Okay, and let's check the picture for question C. Okay, Angela, can you draw question C? Wow, okay.
Sorry, it's kind of hard to do.
Yeah, pretty good. You sure you stop at the right place?
Oh,
Negative.
I realized I did it the opposite way on my graph. Like, so I was trying to like just do it.
Well, the direction is correct, right? Clockwise. Okay, but the stopping place, the terminal arm, I think is not at the right place. Think about how many turns it makes. How many full turns? Let me double check, okay? It can make 2 full turns, right? Yeah, so makes 2 full turns and then 270-degree more. So your terminal arm will end up there. Okay. Okay, if you got the reference angle for both of them, please raise your hand. Okay, let's check answer, okay, for question B. So Jocelyn, what's the reference angle for B?
I got 78.
78-degree, very good, okay, 78-degree. How did you find that? What did you do?
180 minus 102.
Yeah, 180-degree minus 102, okay. Right, and then the next one, question C, is a bit weird, right? Because it's not, you don't see any triangle, but just follow the definition, right? It has to be between terminal arm and the x-axis. So you can do either way, right? Either side, because it's right in the middle, right? So I will need to clear your drawing. Your line is so thick. Okay. Yeah, okay. So we have 90-degree here. Right, one turn, two turn, right? And then 270-degree more. So the reference angle, you can pick either side. You can pick the right side or the left side, doesn't matter. It's right in the middle, okay? So how big is the reference angle, Evan?
I'm not quite sure about this one.
Well, look at the picture, right? How big is this angle?
90.
90, right? Or you can pick the other side. How big is it?
92.
Also 90, yeah. So it doesn't matter. When it's right in the middle, your reference angle is just 90 degrees. Remember,
Okay.
reference angle, we don't care about positive or negative. It's always positive, okay? For reference angle, it's just the size of it that we care about. We don't care about the direction that it turns, even though you have a negative degree, right, for the question, but your reference angle, you just care about the size. Okay, let's take a break, okay, before we talk about the principal angle. So I'll see you guys back here at 11:15. Okay, if you have any questions about homework or anything we covered today, you can ask me during the break.